Welcome. Let's look at what are the different components that a microservices architecture has. So if we talk about different components, there are in general 8 components that any microservice architecture has. First is clients, then we have identity provider, API gateway, messaging formats, database, static content management, and service discovery. So let's go ahead and look at them one by one. First is the client. So if we look at a typical microservice architecture, this is the client layer that you see. And the client can be nothing but a mobile app, a web browser, a chatbot application, or any other client. Let's say in future you build a robot which wants to talk to a microservice. It can also be a client. Hence, these there are different varieties of clients and different types of client which comprise as one of the component of a microservice architecture. Then we have identity provider, and this identity provider helps us do the authentication of our APIs when a client or a consumer is trying to access it. So let's look at the picture again. And if you see here, this client is wanting to talk to our service here in payments, which is built on Java. Then it can go directly. But then if this service is built in such a way that it can only accept requests if it is being authenticated via the client. Then we need to provide a specific identity provider which will make sure this client is being authenticated before this service is being accessed. Hence, this identity provider component is important in a microservice architecture. So usually there are different components that we can use, but Keycloak is an open source identity and access management solution which is quite popular, which can be used for implementation. So let's go and see what is our third component. So the third component in our microservice architecture is API gateway. So services don't call each other directly, rather they call via API gateway. So API gateway acts as an entry point for the client, and then the API gateway forwards the request to the different microservices. So in this picture, if we see, let's say the client cannot directly talk to the payment service or notification service or inventory or order service. The client can make a call via a URL, and this API gateway knows to which service it has to forward the request to based upon the URL. So in the API gateway, there is a mapping between the URL and the component or the backend service. Hence, whenever we make a call to the API gateway, it takes the charge of routing traffic to the microservice components. Hence, the advantages of using API gateway include all services can be updated independently without client knowing. So what does it mean? If we want to update the payment service in such a way that the functionality changes or the URL changes, it doesn't matter to the client because the API gateway is acting as an abstraction layer, and API gateway is now being updated that this is updated, hence API gateway will take care of the outside issues that is related to the client. Then services can also use messaging protocols that are not web friendly, and API gateway can perform cross-cutting concerns such as providing security and load balancing. So what it means is if we want here, now API gateway can act as layer which we can take care of functionalities like security via the identity provider, load balancing when the traffic is too much, which component it should, which instance of a particular service it should route traffic to. These kind of cross-cutting concerns can be taken care by API gateway. Also, the services can now talk in a different format with each other than only HTTP, because now if API gateway understands HTTP, it can intercept the client request, but the actual microservices doesn't have to be only using HTTP as the protocol. So let's talk about the fourth component, which is the messaging format. So the messaging format means these services can now talk to the client via the API gateway in more synchronous forms like HTTP REST calls, or they can also talk to each other via asynchronous calls, which are like messaging services. So let's look at some of the protocols which are asynchronous. So here we have this protocols which are used mostly for asynchronous call like AMQP, STOMP, STOMP, MQTT. These are asynchronous calls, which means once the call has been happened, the client doesn't have to wait for the response. It can proceed with its processing. When the message arrives, then it will be pushed to the client. That's what asynchronous means. But in the synchronous protocols like HTTP REST, whenever a request is made, the client has to wait until the request is served out by the server. So let's look at the fifth component, which is databases. So the fifth component of our microservice architecture is data handling. So every microservice should have its own database. That's very important. So this microservice has its own independent database. This has its own database. So this database can be in SQL. This can be in SQL, but this can be a no SQL database like a MongoDB talking to a Node.js application. Hence, the data handling is like one to one. One microservice has its own database. Then we go to static content. So what happens is sometimes these microservices, when they respond their data, some content is static and they are not going to change. Hence, this kind of static content are returned to a CDN server which caches this data and returns to the client. So whenever the similar request is happening within the same region to this API gateway, the API gateway returns the data back from the static content to the CDN server instead of going to the microservice, which saves a lot of processing power and round trip time. Then we have something called service discovery component. So service discovery is an interesting component where what happens is each of the microservices, when they are starting up or they are down, they registers themselves in a registry which is called service discovery registry, so that now this service doesn't have to be aware whether this service is up or down. Rather, this service is going to talk to the discovery service to know whether notification service is up or not. So it helps, this service discovery pattern helps in easier communication between the services. So these were the 8 components of microservices architecture. So thank you for watching this video. I will see you in the next one.